BIM technology in general provides opportunities for project members to control important variables such as cost, time, and quality in a more efficient and timely manner from early stages, which leads to making more value-creating decisions. These benefits increase productivity and production efficiency. Indeed, BIM benefits are due to the increased information availability and amplified information management. Whether building is a single-family home or an entire city, BIM, once mastered, can help architects and engineers design more efficiently. Indeed, the benefits of this technology have become so clear that governments across the world, such as the UK, are mandating the use of BIM for all taxpayer-funded projects. BIM can improve coordination and communication between all invested parties. A BIM model illustrates the relationship between a building's spaces and systems, revealing any conflicts or problems. Traditionally, these issues might have resulted in errors or omissions in the contract documents, leading to cost extras and potential delay during the construction phase. A significant advantage of BIM and the use of 3D modeling tools is that all drawings, details, the specifications, and even the bill of quantities are derived from this shared model. With sufficient oversight during the production of the model, it becomes easier to avoid coordination errors and omissions caused by a lack of coordination between disciplines, or oversight in the completeness of the scope described within the documents. In addition to generating graphical representation of building elements, BIM models also manage data associated with each element within the building. This data and the model are updated automatically as changes are made to the model. BIM, therefore, makes it unnecessary to recreate and interpret information each time it is handed off between participants. BIM makes the design information explicit and available to all stakeholders and supports decision-making in construction projects through better management, sharing, and use of information. In contrast, project participants in the traditional production environment had their own information systems which were structured and suited for their specialized and specific needs. Therefore, the amount of information that could be jointly shared was limited due to the lack of a central source of information. Today, project data is easily accessible through diverse BIM software, which makes the sharing and control of project information more efficient. In other words, BIM gathers core competencies to jointly decide and address on-site-related problems more effectively. The possibility to perform alternative studies such as energy, lighting, and acoustic analysis of the virtual model is of great importance, especially if the project scope includes designing a building with regard to certain environmental certificates. Standards such as leadership in energy and environmental design, LEED, energy analysis should be performed in the early design phase by linking a building information model to tools which measure energy usage for heating and cooling during peak periods. It allows users to make energy-conscious decisions and test the energy-saving ideas, thus improving the building quality without postponing the design process. Performing deep sustainability analysis in the design stage is a capability that traditional design methods were not able to do. In accordance with aforementioned issues, BIM provides an opportunity to perform value engineering in an early stage, which enables the design team and project administrators to ensure the design intent. BIM has revolutionized cost monitoring. BIM software allows accurate projections of total life cycle costs and costs in the use. The same principles of data management within BIM also allow the total carbon impact of a project over its life cycle to be evaluated. Assemblies and components within the BIM model may be exported directly by manufacturers for fabrication, reducing the need for separate show drawings. BIM works best when more project participants use it. Now, more than ever, the benefits of BIM are increasingly seen to outweigh the costs. BIM implementation requires early involvement of design and construction stakeholders. Although this increases upfront costs, it has been proved overall costs of the construction phase will decrease due to savings gained by avoidance of delays, change orders, claims, and requests for information. The McLeany curve shows the design decisions that were made earlier in the project are more cost-effective, since in this stage the opportunity to influence positive outcomes is highest and the cost of the changes is minimal. BIM technology is not just about a set of technological tools in order to improve old, ineffective processes. It is actually a mediator of innovation that examines and re-engineers all impacted processes and then creates new business processes and strategies. New processes should be employed by construction organizations to fully benefit from BIM advantages, and there has to be a clear plan for implementation and support from top-level management. Traditional interpersonal roles and relationships within the permanent and temporary organizations in an enhanced environment should change, and the new roles in different processes have to be added. New roles are needed to expand knowledge and awareness of BIM within the organization to assure effective implementation. However, a key question still remains: how these roles should be built and introduced within the building project processes. BIM aims to maximize the workload in the early design phase. The following graphic shows in BIM system nearly 75% of design decisions should be made during pre-design and schematic design phases, whereas the remuneration in these phases is only between 5 and 10% of the total project fees. This indicates that the remuneration has to change due to the new project development system. Many organizations have witnessed the transition to BIM to be predictably slow. They usually face challenges related to productivity, availability of skills, and process integration. Whenever a new system is put into place, there is almost always an immediate dip in productivity. With time and investment, productivity climbs back to where it was with the original system, with the recovery of the investment made in the implementing the change seen as a long-term goal. Although organizations have some staff members dedicated to using BIM tools from the beginning, most of the more technically experienced architects and engineers, fearful of the impact the change might have on their performance, are reluctant to abandon established methods and familiar software. Young staff members, however, who may have been more open to experimenting with BIM, don't have the practical construction experience to use the software to its full advantage. A strong understanding of design and construction fundamentals is fundamental to using BIM effectively. Despite these challenges, dedication finally pays off. Improved productivity and the financial benefits of using Revit and BIM clearly surpasses the initial productivity loss and financial investment, representing a net gain for the business and strong momentum for the future.